Okay, so the recording started, and once again, thank you for joining. And before we continue, I want to introduce our community, especially those that might be new. This is the official AWS user group for Kosovo. The group is established in 2019, and now we have more than 400 members. Polymath Labs has been serving as a community founder and sponsor. The purpose of this community is to help our members learn more about AWS and level up the expertise through presentations, discussions, meetings, and workshops. For those of you that are not familiar with Polymath Labs, we are a company, a software development company with headquarters in New York and operations office in Pristina here. And we specialize in developing modern applications on AWS and have been developing cloud-native solutions for a wide range of businesses so far for the past 4.5 years now. We are strong believers in serverless, such as Eric. We believe in event-driven architecture, asynchronous software solutions, which also happen to be the topic of the today presentation. We are grateful to present our featured speaker today, Eric Johnson, which is a principal developer advocate serverless at AWS. Eric is a fanatic about serverless and enjoys helping software engineers to understand and utilize serverless technologies better. Today, Eric is going to talk about asynchronous applications, event-driven architecture, and which is really important in this topic is store-first approach for higher application reliability. Eric, thank you for joining us. The floor is yours. As a reminder, we will be observing the chat for questions and we will give the floor to those that raise hand. There will be also a Q&A session at the end, so please keep notes about your questions. Okay, Eric.
Thank you so much. I appreciate it, and I'm thrilled to be here. Hopefully, y'all can hear me okay. Normally, I have headphones on. I have had every technical difficulty you can have in a morning, all on my side. But I think we are good to go. So if there are any problems, let me know, and glad to adapt here. But I'm thrilled to be here. I'm going to actually share my screen, and then we can kind of so let's do this real quick here. All right. So, and then I'm going to, okay. So y'all can see me okay, hopefully.
Yeah, we can see your screen.
Great. Yeah, it's jumping around on me. There we go. So today we're going to be talking about thinking asynchronously. And I'm a big believer in thinking asynchronously. It's critical to building applications in today's modern world, but it's also really critical with serverless and serverless is purpose built for this. When we talk about serverless is kind of that architecture that we build, and this is not an intro, so I'm not going to be going deep into this, but serverless is the idea of I don't have to manage servers, I don't have to patch, I don't have to do all the things that go with servers when I build applications. Instead, I just worry about code. When we talk about solutions, we talk about event-driven architectures. That code is used to build event-driven applications. And this is where thinking asynchronously becomes very powerful. We'll talk about some of those concepts as we're going through today. Now, a couple of things, and I think I'm going to bring this up here if this makes sense. And then I'm going to kill my, that is not what I wanted. Let's go here. And then I'm going to take my camera off, and I think we are good to go. All right. Everybody can see me hopefully here, and I can see what I'm doing. A couple things real quick as we get started about me. Again, I'm an EDJ Geek on Twitter, if you're following. I am a principal developer advocate for serverless. I am a freak about serverless. I remember the day they announced AWS Lambda. I was watching the announcement at reInvent, and it clicked in my head. It was like, oh my gosh, why would you do this any other way? And so at that point, I jumped in. I am a father of 5. I'm a husband of one. That's not a typo. My family's crazy. I have 3 boys. I have 2 girls. And we go a million miles an hour. I'm a drummer. That used to say musician, but people debate whether drummers are musicians. I believe we are, but I thought honestly, I thought I was going to be a drummer for a living. I went to school of music. I played in bands and stuff like that. And it turns out I'm a really good drummer for one finger, but I'm fairly average in the real life, and nobody was going to pay me to play drums. I am a pizza lover. If you follow me on Twitter, you hear a lot about pizza and why pineapple should never be on pizza. And I run on Diet Dr. Pepper. I have my Diet Dr. Pepper with me at all times. I'm not trying to push it on people, but I know that this is how I survive. And I'm a great artist. That's not true. I'm a horrible artist. Today we're going to be, what you're looking at right now is my virtual white screen. You'll see me drawing on here. Man, I'm gonna be straight up. I am not a great artist. I did not draw that picture of my face. A good buddy did. So bear with me. But I like this whiteboard approach because we can kind of walk through this conversation about serverless and about thinking asynchronously. Couple of rules while I'm talking, and even though we're virtual, it's not really rules, they're guidelines, but they're going to help you. The first is, this is any number I want it to be. Earlier, you noticed I said I'm a father of 5, I'm a husband of 1, and if you were following closely, you're like, only one of those were right. These are thumbs. Not, I do this all the time. And then these are quotes, not apostrophes. I know that this just takes a long time. I make 1-figure jokes. It's okay. I was born this way. I didn't wake up for the first time this morning like this. If I did, I wouldn't. I'm gonna be really honest. I wouldn't be in this show. I would be somewhere trying to figure out what happened. Right. So I hope that doesn't make you uncomfortable. Either way, I'm gonna be okay. So let's get started. So we're going to jump into the idea of thinking asynchronously. Now, full disclosure, this is more of a 300 level talk, 300 or 400 as far as when we're talking serverless. If you're brand new to serverless and some of this goes over your head, don't worry about it. We'll talk about concepts, but these are things that you can go back and grasp as you get more into it. So, all right, here we go. So you're going to see me kind of looking down because I'm looking at my tablet while I'm drawing, but when we think about building applications, right? So we look at it in serverless, a very, very common pattern is we will just set up a simple API. There we go. And then we'll usually have a Lambda of sorts or compute. Let's just say compute for the moment. So let's say we're not even talking serverless. And then we'll have some sort of database, right? And this is a very simplified version of an architecture, but this is how we build it. So our person here we go. Again, I'm a horrible artist, but I do like to have fun.
Could you say that again?
Oh, Siri's talking to me
I'm
here.
having
So
trouble hearing you.
okay, so we're just gonna take Siri off here and let her there. So you have your person. They make your call to your API. The API then, and this is usually now in modern development, this is usually an abstracted API or an API gateway in front of our compute. Sometimes it'll be built into the same system, right? Your code, you're actually handling that in your compute. Then the compute does some business logic. Maybe we transform a request. Maybe we do some business logic, get that. And often we'll make a call to a database. We return that, come back to the API, and it goes back to the user. And this circular system here is synchronous, right? So when the user makes the call, it's a blocking call. The request makes the call, and we wait. And then we wait while this compute is happening. We wait while the database is being called, and we get everything back. That is a synchronous way of building an application, right? Now so what's happening here is in the API gateway, we're probably and we'll go to a new screen here because it's getting kind of full. But in the API gateway, we're doing several things. We're handling authentication, authorization, usually just authorization. Our authentication is handled somewhere else. We're doing maybe some data validation. If you're using Amazon's API gateway, you could do some data validation. You might be handling throttling, and you can do caching. And there's all kinds of things going on at the API gateway, right? And then in your database here, this is where you're storing things, right? So this is your storage. This is, this could be a DynamoDB database. It can be a relational database, in anything going on. And so I'm getting a warning. It's saying infinity mirror. Y'all aren't seeing an infinity mirror, are you? It's telling me it's having issues showing. Mom, can you see my screen okay?
Yes, I can see your screen.
Okay. Google keeps telling me that I'm about to blow up everything. So, okay, so we're going to continue. All right. So your storage is where you keep your data and all that kind of stuff. And then in our compute, this does everything else, right? I mean, we apply business logic. Sometimes we do our authorization there. Sometimes we do all kinds of things, right? So the problem with this, or the problem that I'm going to throw out, is this makes an application somewhat brittle, right? And let's talk about why on that. So if our compute is doing so many things, so we go back to our process, it makes the request, we do our business logic, we talk to the data, and then we return it all back to the user. What happens when this fails, right? So when this fails, the request is done. We've kind of got a problem in that that's the end of the request. We have to go back to the client and say, I blew it. We kind of do that error handling at the client saying, hey, we know you just gave us a credit card number and we're supposed to charge you thousands and thousands of dollars, but we blew it. So, but we want you to trust us again. And so we're going to try this again. Now, even more so, and I'm going to be really honest, my name, my title, I'm a principal developer advocate. Developers right there smack in the middle, right? I'm a developer, but honestly, I'm probably not the best developer in the world. And what happens is you're relying on Eric Johnson's code to handle this, to handle this system. And there's a good chance that periodically, hopefully not, hopefully I've done my testing and I've run it against the systems and I've got my unit tests, my integration tests, and I have full coverage. Hopefully I will never introduce a bug. But the reality is I probably will at some point, especially if you hire Eric Johnson as a developer. I'm going to introduce a bug at some point. So what happens is, like I said, we're taking customer data, we're trying to make that work, and it blows up, and we got to go back to the customer and say, hey, things kind of fell apart. Even in serverless, things kind of fell apart, and we need to get your credit card number again. Right. So if you're familiar, and I'm not going to tell you that serverless never breaks down. We believe it's very robust, and it probably breaks down less than most other architectures. But the reality of life as developers, and Werner Vogel says this best, is everything breaks all the time. At Amazon, we build for robustness. We build hoping that things don't break, but we also build in case they do. That's why we build multiple zones. That's why we build redundancy into our databases and our services. And that's why we build retry into a lot of systems. We build knowing that things are going to fail. And so with this idea that we're going to climb into here, I want to help you build on serverless, knowing that things are going to fail. Okay, so what we're going to do here is we're going to switch this up a little bit, okay? And we're going to get to the asynchronous part in a minute, but right now, this is completely synchronous, right? Remember, we talked about when we were talking about here, this idea, it's a roundabout system, it's completely synchronous. And if any part of it fails, we're in trouble. So how do we fix that? What approach do we take to kind of change that up? So here's something. And this is a term, I don't know if I coined it or somebody else, but this is a term that I've been using lately that kind of helps explain the concept. So remember, we have in this, and actually I'm going to go to black on that. So in this, we have our API gateway. We have our compute, which on serverless, that's going to be a Lambda. I probably always get that wrong. There it is. I think that's right. All right, so that's going to be a Lambda. You're probably like, Eric, you should know which way a Lambda goes. Yeah, I forget a lot. And we're going to have database. In this example, we'll use Dynamodb. Okay, so this is our normal one. But what if instead of going from API gateway to Lambda function to DynamoDB, what if instead we reverse these? Okay, so I said instead I'm going to go API to DynamoDB to Lambda. Let's talk about a couple things. Okay, here's what that gets us. This now becomes, so at a broad scope, this now becomes asynchronous, because now I'm going to do it based on an event in DynamoDB. Let me explain how this works. So I can set up API gateway to directly integrate with DynamoDB without any Lambda functions in between. It's not for the faint of heart. I'm not going to lie to you. We use what's called VTL, which is velocity templating language. And this allows you to modify a request coming in from an API. So let's say we have a translation application we're going to build. And in this translation application, we're going to send a string of text and then an array of cultures. Okay, so we say we're going to send in some data and we want you to convert that text to these 5 different languages. Let's say it's, we'll go Dutch and Spanish and, whatever. So we'll do all different things and then return that. So I could up here pass this here and then have the Lambda start doing that work and then write it out to DynamoDB. But instead, I can write that data directly to DynamoDB. Okay, so API gateway using velocity templating language to modify the request. I can form that data coming in as it should look for a direct put object into DynamoDB. And DynamoDB has an API call an API that we can call to place that data. So what happens is when I put that data in there, then with DynamoDB, I turn on a thing called streams. Now, DynamoDB has this idea as you put data in, you can log out the backside of it in what are called DynamoDB streams. And those streams hold the data. This record changed to this record. This is a new record. This is an old record that got deleted. And so you get a log of everything that happened. And that DynamoDB, that stream can directly invoke a Lambda function. Now, let's talk about the advantages of this a little bit, okay? So if I do that, let's go to a new page really quick. And actually, before we do that, I'm going to jump on and see if we have any questions coming in. I'm glad to I don't see any at the moment, but if you're looking at this, go, whoa, I don't get it. Feel free to throw a question in, and I'll stop at some points to do that. Also, feel free to interrupt me. So. Okay, I don't see any questions coming in. All right, so let's talk about some advantages of this. Okay, so again, we have our API, we have our database, and we have our Lambda function. When I write to the database, the first thing I have, and then I go to my Lambda function, first thing I've done is I've persisted the data. Okay, I call this pattern storage first. There's lots of different ways to do it at AWS, but this is the one I'm choosing at the moment. But I'm persisting the data. So what does that mean? So with API gateway, I've written the data, and let's say for some reason that data, now I've written the data and everything worked fine, and now it's in that stream coming off the back, and it invokes the Lambda, and wouldn't you know it, something goes bad in my Lambda function, and now I couldn't perform whatever business logic I needed to perform. So what's the system here, or how do we handle this? Do we have to go back to the client? We don't. And the reason is that data is still here. It's persisted in DynamoDB. Okay. So what I can then do is if something goes wrong with that Lambda function, I can just leave the data. Okay. And then I can maybe have another Lambda that runs a periodic check every hour or so and checks to see if there's any data that didn't get processed. And what's happened is without going back to the customer, I'm still working on that. But it's an asynchronous, and this is where we get the title, thinking asynchronously. When the customer makes the commit to DynamoDB, they're going to get a response immediately that says, hey, it's a 200, all is good, we've entered that data, and we're doing some work, right? Rather than doing all the processing first, we simply stored the data. And so what happens is the customer now no longer has to watch the spinning wheel while we're waiting. Instead, they're able to get an instant response. Now, is all their work done? No, but they don't have to be there while these things are happening. And this is what we call, this is part of the event-driven architecture model, or it's thinking asynchronously. It's working with events that are triggered after the customer or the client or the caller or whatever has started this process. Hopefully that makes sense. If it doesn't, I'll watch for questions in there. But the advantage here is if this fails, I don't have to go to the customer. I simply run it again. I could trigger, hey, this failed, so I'm going to trigger something else. I'm going to use a DLQ. It kind of depends on how it fails. If it's your code that fails, then you can process it, do whatever. If the Lambda service itself fails, you can write it off to DLQ or test it again later. So that's this idea of when I think asynchronously, how's that going to work? Okay, so let's apply this to an actual practical example. And to do this, we're going to build a translation app. Now, one more advantage of this, actually, before we step on, if you think about the stream coming off, let's say you need to do a bunch of different things, and we'll talk about this in the app. But in our old process, okay, and let's explain this real quick. In our old process with API, we would go to a Lambda function. What we would end up doing is, let's say we had to do 1, 2, 3, 4, 5, 6 different things. We need to, let's go back to our translation example. We need to make a translation. We want to convert that translation to an audio file. We want to run comprehend against it to see if they're happy or sad. We want to save it to a bucket. We do all kinds of things. So would have to linearly do each one of those. So you would have 1, 2, 3, 4, 5, 6. And that's a linear process. Get this translated. And if you had more than one, let's say we have multiple cultures, then it would have to do it for each one. So each of these processes. So there's a couple of issues with that. Number one, you're running into that, if it's a lot of stuff, you're running into that 15-minute limitation that happens on a Lambda function. Number two, if any of these fail, let's say this one fails, you lose it all, or you lose parts of it, depending on where it's at. If you're using temporal memory, if you're saying, look, I'm doing all my processing in a Lambda function, and then I'm going to save it to a DynamoDB database or a database of some sort, then or S3 or something, then you lose it all because one part of it blew up. Okay, so when we're looking at resiliency in applications, we want to make sure how can I reduce the chance of losing data? Losing data is losing credibility with customers, right? If I have to go back, if I'm a customer and I've made a payment, it comes back, your payment failed, that make one, it's like, whoa, did my credit card bounce? Or did my credit card go bad or something like that? And if it happens a couple of times, man, I'm going to move on. I'm going to buy it somewhere else. So resiliency and credibility are tied together, and credibility for any customer is huge. I mean, that's currency, right? I'll pay more somewhere I know that my money's safe, my transactions are being taken care of, than I will for somewhere where it's cheaper, but I'm getting errors. I don't know if this worked. Yeah, customers don't want to do that. They also don't want to watch the wheel spin for a long time. So with the new way, what you're able to do is when the API call is made and it's put into DynamoDB, then I can then trigger multiple Lambda functions to happen. Right, and so I can do the 1, 2, 3, 4, 5, 6 things in 6 different Lambda functions. So what I've now done is instead of working linearly, I'm now working in parallel. And it reduces that time. Rather than doing one thing, then another, then another, then another, I'm now doing all those things, if possible, at the same time. Parallel processing is critical when you're thinking about in event-driven architecture and serverless architecture is, I mean, it is purpose made for parallel processing. Don't do it linearly if you don't have to. Okay, so hopefully that makes sense. All right, so let's talk about a practical example of this and see how we apply it. I am going to stop and see if we have any questions. Mohammed, do we have anything going in there?
No, we don't have any questions unless someone has something now, but no one wrote.
All right. Okay, so it's making sense, hopefully. Okay, good.
Yeah.
All right, so I built this app, and it is a translation app. Okay, and the idea was we long ago when we first started talking about if you've ever heard of our workshop called Innovator Island, we talked about the idea is what if we had a set of language or set of messaging or signs or audio files that were in one language, and we needed them for all the different languages of folks that are visiting our theme park. How could we quickly translate those? And so what we wanted to do is take and we wanted to say, I want to first translate the languages, like we said. Then I want to convert them to Poly, or use Poly to convert them to text. Eric cannot talk to convert them to audio. And then I also want to run a comprehension on it, just in case. I want to make sure it's happy and there's no bad words in it or anything like that. That I need to save it to Dynamodb. And I need to save the audio files to S3, and then I need to then build out, then I need to make it so that those are available to customers when they want to listen to it. So here's how we do that in AWS. So let's take a look. So here's how we would first do it. Okay, so we build this website, right? So we have our user over here. Okay. And what they're going to do is they're going to send to an API. It's going to have a string of text. So we'll just say hello world, but they could be much longer, like a paragraph or whatever. And then it's going to have an array, and in that array will be cultures, US, ES, something like that, stating the language and the culture. Right. So there's 2 different things part of that. Okay. So we'll send that data. What'll happen is we'll send it to an API gateway, and then it'll go to a Lambda function. Now we'll use Cognito for authentication, and we'll use Amplify for hosting because this is our front end, right? So we'll do those 2 things, and then the Lambda will then call translate for each culture. So the Lambda takes and says, okay, for each culture, I'm going to break it out, and I'm going to do 1 request per culture. So the Lambda says, I have hello world, and I need it to be in German. I have hello world, and I need it to be in Spanish. Okay, so what it does is, let's say there's 4 cultures here. It actually sends 4 requests to translate. Okay, but it has to do them linearly, right? So it sends request 1. It sends that request to translate. Translate takes and converts it to the culture, sends it back. Then it sends another one. We do that linearly, then back, so on and so forth. So 4 times it does that request to translate. So the next thing it does is it takes each of those. So now it's stored this array of translations. Okay. So the next thing it's going to do is it will send that to Poly. And what Poly will do will take that information, and it will it will set up, and so you're sending that text, it'll create an audio file of that text in the language and the voice. You can pass some information to make that happen. Then it'll then send a stream back or a buffer to the Lambda function. So again, now I've got 4 translations, so I'm going to do this 4 times. Okay. Once those are done, then what I'm going to do is I'm going to save the languages to DynamoDB. So we're still just the text, right? So I'm going to save, and I can do this in a bulk update, or I can do them one at a time, either way, depending on how many they are. So let's say we do it in one at a time. So I'm going to save 5, actually, the original language and the translations as one or more records in DynamoDB. The next thing I'm going to do is I'm going to then save the audio buffers, convert them to an S3 bucket. I'm going to come down here and save those out. And then once it's done, then it comes back to the API. I then return to the user. Okay. All right. So like we were talking, as we're building this out, hi, Mark. Mark said, hi, guys. Hi, Mark. As we're building these out, if any one of these fail, here, or here, because we're doing 5 times there. So you have 4, 8, 13, roughly 18 possibilities for this to go down. So you've increased your chance of error by 18 times, right? All done, and it's done linearly, so it's going to take a while, right? So here's what that looks like. So let me pop up here my client. Now this works. So I'm not saying this won't work, but what I'm saying is it the best? Let's take a look here. All right. Hopefully y'all can see that. And ignore this so I can make sure. Okay. So I built this little client. It's not pretty. I am not a designer by any means. I actually started in the tech world as a designer, and the truth is, you can give me a canvas and say build something cool, and 3 hours later it'll still be a blank canvas. The creativity is not there. I know the tools, so I became a developer instead. So all right, so we are in the synchronous serverless translator. So real quick, I'm going to go to aws.amazon.com/blogs. And we'll just grab a new Twitch series here. Let's hopefully y'all can see that okay. So I'm just going to grab a set of text, right? So we'll grab the AWS Power Hour. So we're going to grab this whole paragraph. So in our translator, we can go in and I can create a new translation, and I'm going to enter the phrase we want to translate, something kind of large here. And I can choose 1 or more languages. I'm actually going to choose all of them. These aren't all the languages supported. These are just a group that I put in there. So now, when I hit translate, when I hit translate, watch what happens. Now, it's a blocking call, so we're waiting for this to work. And so now my user's done. They can't do anything until this is complete. So we're waiting and we're waiting. Oh, okay, there it worked. Now, that wasn't horribly slow. And some of you may be, Eric, that's acceptable. It worked. Everything went fine. But what if I'd have been doing the first chapter of War and Peace or some other large piece of work? That would have taken a long time and possibly timed out. But we can go in here, and you can see here that here's the original text, here's translation, Arabic, Chinese, Danish, German, English, so on and so forth, all the way through. And you can see them all, and if I want to play them, you probably won't hear this.
Power Hour, SysOps está diseñado para...
But I can play that, and so it gives the idea. But again, going back to our drawing here, we have this potential of it kind of blowing up because we're doing it synchronously, and there's a lot of ways for that to go wrong. So let's redo this in the way we were talking about. And this is just one of the options. All right. So now what we can do is if I take our let's go back to our process here. We got our user, same data. We're not going to change anything. Same data. Okay. So the user submits to API gateway. Then what happens is we're going to place that data using API Gateway. And I'll actually show an example of what that looks like in a little bit so you can see, oh, is he really doing this? Yeah, he's really doing this. We're going to place that data directly into Dynamodb. Dynamodb. Okay, wow, Eric Johnson. Okay, DB. There we go. Then what's going to happen is in the stream, for every event that's created, only created, and I can run some filters on this to say, I don't know if you saw, we just had a brand new one, but filters that say, it has to match this certain criteria. And this will actually come in really handy in this particular example. So real quick here. All right, so what we're going to do is we're going to drop that into DynamoDB, and then I'm going to put one Lambda function here. How you doing, Eric? Let's see. Yep, there we go. And what that Lambda function is going to do is it's going to call the translate service. This is a machine learning or artificial intelligence service that Amazon has, and we're going to call that translate service. And we're going to actually call it for, and like I said, there's a lot of different ways we can do this, and we'll get in. Actually, we'll do this a different way. One second here. We're going to use event bridge in this. Now we still need the Lambda function. So, and I did use event bridge. So the Lambda function gets invoked, and it takes that request and it puts an event on, yeah, that's how it works. It puts an event on the bus. I was just trying to think how I did it. We're going to do an event bridge bus. So let's say we have our 4 languages again. It's going to create 4 separate events, right? It's going to say we're going to create four translate request events, and we're going to throw them on this bus. And then that Lambda is done. It's done its work. Asynchronously, and this is that fire and forget idea, it's fired off this request, and then it goes away. So this Lambda will run for maybe 200 milliseconds, okay? As those events go in, then we're going to have a Lambda up here that watches for translation requests. And it's going to say, oh, okay, I see 4 requests. Now, the cool thing about this is each one of these requests that are translate are going to invoke a separate Lambda function of the same code. So again, we're in parallel, all right? So 4 events, Lambda's going to go, oh, okay, yeah, I got that. I'm going to trigger these events based on this rule. Let's go ahead and do that. Each one of these Lambda functions are going to call translate and get the response back. So now, each one, let's do the line here. So that's 4 different calls against translate. Then when they get that response back, they're going to drop that data back into DynamoDB. Now let's talk about that for a minute. What we're getting out of this, yes, you're like, Eric, you're still doing 4 different things. That's right. But number 1, I've persisted the data here, first of all. So I'm not losing data if something goes wrong. Number 2, if this Lambda goes bad, this Lambda is still good to go. This one's good to go. This one's good to go. It does not shut down these operations. You've decoupled those individual event processes, okay? So that allows you to do that. If all of them go bad or there's a Lambda service problem, then your event bridge bus is going to do some retries, right? So again, you have retry logic built in there. All of this is without you having to code for that, okay? This actually reduces the amount of code. So you're getting the call, it drops to the database, we invoke a Lambda that separates them out into events. If this one fails, the data's still here, right? And then, boy, this is getting messy and hard to read, but then it goes and it makes the calls, and then everything gets dropped back into the database. All right, so any questions on that so far? Watching here, I don't see anything. Great. All right, and I want to be sensitive of time. We are stopping in 15, is that right?
Yep.
Okay, good. All right, we're good on time. Okay, so here's what's cool about it. We're going to do a new page, but I won't draw the whole thing out. Here's our database. Sorry. Okay. Now, All those translations have now been dropped in the database. We have those translations. Well, here's the fun thing. I can then kick those go into the stream, right? So I can then invoke that Lambda, and I call it my, it's my router, whatever, that Lambda, and he can say, okay, I'm going to put, now I'm going to put a new request in the system. Into the system, I'm going to put poly requests. I wanted to change these texts into audio. Now, I could have also, on this previous one, I could have had these Lambdas then drop those onto the event bus as well. But, and that's fine. That would work fine. I drop them straight here because I want that data persisted as fast as possible. I don't want to risk losing that data, and I need that data saved to Dynamodb. So I'm able to kind of do this circular invocation. So now that we've done our translation request, now we're going to do a poly. So we have another Lambda function that is set up to get a different rule that says anytime a new translation appears, because remember, all we had was the first request. Now we have translations that are in here. Now those should invoke an individual Lambda function. And those will call poly, and we'll just put a P there for that. And they will call poly with an asynchronous request. They don't have to sit there and wait with this. This is something poly can do. With poly, I can say, I want you to take this text and convert it to audio. And then I want you to drop it in this bucket. So we've got our 4 translations launching different Lambda functions. They call poly. They pass their own individual version, DE, SE, ES, whatever. It's converted, and then it's dropped into this S3 bucket. Okay. So when that happens, now let's recap here for a moment. So far I've got the original request. Let's change color. I've got the original request, and in my data I have the 1, 2, 3, 4 translations. So all my data is persisted. I haven't lost anything. Now what's going to happen is that data is dropped into the S3 bucket. When that work is done, I can then invoke, for every new file that's dropped in here, I can invoke another Lambda function. And his job is to go do 2 things. Number 1, it's going to record into the database, and I pass through naming scheme. I'm able to pass some data into the database. It's going to record the location of those MP4 files. It's tied to the right ID, everything like that. Number 2, it's going to call that S3 bucket and add an access control list that makes those publicly available. So what I've done here is I've invoked yet another Lambda. I've called poly here. Poly has dropped the data into an S3. The S3 has invoked this Lambda function, which stores the data and saves the ACL. Lots going on here, but all based on events that are getting passed around through the system. So at this point in our database, we have, let's say, we have the original request. We have 4 translated strings of text, and we have 4 location addresses of the S3 files in the bucket. Any one of those could have been lost in it. Maybe my code was bad, things like that. But like I said before, I can write a Lambda to look for an original request and verify that everything else exists. Kind of a self-healing idea, right? All right, so the last thing we're going to do, let's say we drop on the original request. Let's say we come in after the fact. You know what? We want to use comprehend, which is machine learning, and we want to know, what does this, is the person who entered this text, is this text happy? Is it sad? Are they angry? I don't know. So using the same cycle, we know that when this original request is imported, it's going to get added to the stream. So all I need to do is I can do this a couple of ways. I can have my Lambda function create another request on Event Bridge, or I could just, because I now have filtering, I can invoke yet another Lambda on that one and say call comprehend, get the analysis, and write it back to Dynamodb. So then I have yet another piece of data for that single record. Now, that was a lot of information I just threw at you. And I'm going to actually show it to you in action and see what we have here. So let's go back to our example application. Let's take this text and we're going to go home. Now I have my asynchronous version, and all this does is change the API I'm working with. I have this application launched twice. One's synchronous, one's asynchronous, like I just explained. So I'm going to go ahead and create a new one here. Choose the same text, and we're going to translate to all these different ones, just like we did before. And watch what happens when I click translate. And we're done. Now, that was a little different, wasn't it? My client's not sitting around waiting. Even if this was a huge amount, I can go into it, and you'll notice not everything's there yet. The audio is still rendering because it's going through and doing these event, it's got the events set up, but it's still rendering. But it'll get here in just a few minutes or even shorter, and there they go. So now they're starting to appear. Now, I can do this from a client side. You may be asking, how am I getting these updates? You can do it two ways. One, I can use WebSockets through either API Gateway or AppSync, or I can just pull. In this particular example, I'm pulling every 5 seconds for updates. Most of our audio is here. Now, and then if we go back to the home, you'll notice my sentiment. I now have a sentiment on this as well, and that's neutral. It says, nah, nobody's mad about this. It's just a simple paragraph. Okay. I've just thrown a ton of information at you. Hopefully this makes sense. And I'm in just a second, I'm going to open this up for questions. But I'm going to take you one more level on this before we go, and hopefully this makes sense. I built a lot of this. I actually built this example quite a while back, and I hadn't really encompassed step functions in my life yet. The next logical way of doing this would be in step functions. And step functions is really purpose-built for this. You can still do it all on event-based, but you could do this in a single step or in multiple step functions or a single one. And instead of going to DynamoDB and doing it off the stream, you could actually orchestrate it in step functions. And the reason that would work is because step functions still allows you to persist somewhat your data. Step functions has built into it retry, error handling, things like that. That if something goes wrong, you can do it. I tend to look at how I want to persist before I decide how I'm going to do this. DynamoDB is forever. So if I'm writing data that I'm keeping forever, then I just go straight to DynamoDB, and maybe I'll trigger an event off of the stream to do step functions or Lambda, whatever. If it's data that I'm going to process and then goes away, then I'll use something a little less timely persistent, like step functions or SQS or SNS. So when you're looking at this, again, this moves us from synchronously moving, the request is all tied together. Once I start it, I have to wait till it's done, to a matter of events that are handled after the request is made. And this is really the pattern for thinking asynchronously when you're building event-driven architectures. And with that, I'd love it to answer some questions. And there's no question I won't try to answer if it doesn't even relate to this, serverless related. Why don't you like pineapple on pizza? I'd love for you to come on screen and chat with me and tell me what you think. And I'm going to stop the sharing, and we'll go to questions.
Okay. Thanks for the great presentation, Eric.
Oh, you bet.
Yeah. So yeah, we have some time remaining for question and answers. So anyone? Okay. Arbin has raised hands. Then we have Florian. Yeah. Arbin,
Okay.
can you please?
Yeah.
Yeah, hello. Thanks for the presentation, Eric.
Yeah.
Happy to hear you. I had a question regarding, in the cases of rollback, is this a good approach, or how can we handle it?
Yeah.
When we need the rollback transaction.
Okay. So you're talking more like transactional. Hey, if one stops, everything.
Mm-hmm. Yeah.
Yeah. So there's a couple of ways you can do this. One is you can depend heavily. DynamoDB actually has transactions built into it. So if it's data, if you're making some changes and you're making a bunch of changes, that would handle it. But that's kind of all in one call. You're updating some things. In this, you would probably need it because this is a very distributed, decoupled way of building the architecture. So what if you need an entire rollback? What you would want to do is look at either one, monitoring that in the code, and we talk about this when we write like idempotent Lambda functions as well. You want to check for existence, things like that. But we also want to check, did all of this finish? So you might write one final Lambda function that says, okay, so let's use this example for a moment. If I've had a request and I've gotten all the MP4 files, that's the last in our process. But if I have a request, I can set a time. I can say this initial request came in at, let's say, 2 o'clock. If by 2:15, I can trigger that Lambda function to run. If they don't all exist, then delete it all, drop it in DLQ, mark it, somehow do something to it that says I need to roll that back or this needs to be redone. So that's a good way of monitoring that action. Does that make sense?
Mm-hmm.
Okay.
Yes. Thanks for the answer.
You're welcome.
Okay, thanks. Sorry.
Yeah, Eric, as you said before, decoupling. Do you mean that it is a must to use SQS in this case?
Say again, I'm sorry.
When you said decoupling databases before, so is it a must to use also SQS in this case for queuing?
So you can. So, and the fun part of AWS is there's a lot of overlap in services, right? There really is. EventBridge, SQS, SNS, but they're built with specific purposes in mind. So if you need to queue up stuff, right? So there's a slight difference between a bus and a queue, right? A queue is I'm going to queue up a bunch of stuff and I can process those in batches. And that's where SQS comes in really handy. So for example, let's say you have a downstream process. Let's say you're proxying some kind of legacy service that can't handle the load of stuff coming in. This is when a queue makes perfect sense because you can just fill that queue up with just tons of them and then do batch processing against it as needed. I chose EventBridge in this particular example because even though I have a bunch coming in, I still want them to be run one-off. I don't want to batch it. As the 4 came in, I want them to rather than one Lambda grabbing 4 translation requests, I wanted 4 different Lambda functions to be invoked by the 4 different events in the event bus. So slightly different ideas of how those work. But I mean, yes, I could have built this in SQS as well. In fact, I don't know if y'all are familiar with Jeremy Daly, but Jeremy Daly and I have many late night dinner debates. And I am a Dynamodb. And the first time he ever saw this, he goes, "Oh, I would have done that with SQS," and that would absolutely work. It just, for me, it made sense because DynamoDB is persistent always, and I wasn't, SQS can keep it until you've processed it, then it's gone. But in this example, this is data I wanted to keep forever, then it made sense. But if it were just data I want until it processes, then SQS would have worked just fine instead of DynamoDB. Did that
also, yeah, thank
Good.
you. Also, when it was audio rendering, so what if audio rendering will be more than 50 minutes, since we know that Lambda will be maximum running in background 50 minutes. What about them? So are we obliged to add more Lambda function, or what do you think?
Yeah, that's a fantastic question. That's actually the problem this solves. So in the original build, if you remember, I had the Lambda calling Polly to create audio and it returned a buffer. And you're absolutely right. There's a good chance that's going to take longer than 15 minutes and you got a problem. But in the second version, the one that I showed you, I actually just sent the text to Polly as a request and said, here's the S3 bucket to drop it in. At that point, the Lambda goes away. It's a and forget idea. So this asynchronous process says the first Lambda sends the data and then it's done. So there's no timeout there. The second Lambda doesn't invoke until the audio file is complete and dropped in an S3 bucket. And all it has to do is grab the address of that and write it to Dynamodb and then set the ACL. And that's going to happen in less than a second or two. So this is exactly, but by changing to asynchronous patterns and event-driven asynchronous patterns, it gets you away from that synchronous waiting in a Lambda function until a process is done.
Yeah, so idea is to make it asynchronous, right? In order to
Yes.
reach the target.
That's right.
Yeah.
And many of our services offer that. Polly being one of them, off the bat, it offers that ability.
Yeah. Thanks for your answer.
You bet.
That's it from my side.
Okay.
Thanks, Florent. Donat?
Hi. First of all, thank you for this lecture. And my question is, are we adding delays in our apps by saving the data first and then processing? So with this approach of saving data first, are we designing reliability over interactivity?
Absolutely. And I love that you asked that question. This pattern will not fit every workload. And that's a really good call out, Donat. I appreciate that. This pattern is not for, there are some where I need an instant response, right? So I get that. And that's what Synchronous is for, right? We know that. And so this is not in an effort to say never use Synchronous. Sometimes you're going to need to. Gaming is a great example, right? With gaming, you can't go asynchronous. And, we'll tell you if that shot worked or not later. So this is a balance of evaluating the application and going, what can be asynchronous and what needs to be synchronous. What I find is people tend to go all or nothing on either. Everything's synchronous, just do it that way. Or everything's asynchronous, like that. So you have to look at your pattern, your data access patterns, and say they need an instant response on this, or they can wait a little bit for this. They don't need to be there while I'm translating all this. So yes, really good call out. This is not for everything. That's why we support both in serverless.
All right, thank you.
Yeah.
Thanks a lot, Eric. Armand?
Okay, thanks, Eric. You had a great use case for using asynchronous.
Thank you.
But in the beginning, you mentioned the use case when user is paying for something and data is not stored, because usually the data is stored first and then it's charged, whatever. So in the UX perspective, maybe is it better to wait a couple of milliseconds to make that charge and verify if that charge is correct and throw the error to the client, and not wait for processing later, because I think the user needs that response immediate. And asynchronous processing of the charges, I think it causes more confusion to the user. So
yeah, so really good call out. So one thing I would say is not all storage first patterns have to be asynchronous. And let me explain what this means. And actually, I'm going to share my screen. Are we okay on time, man?
Yeah, we can. A few more. Yeah.
Okay, let me sorry, let me move this over real quick here, and then I'll share my screen, and then yeah, because I actually want to address that, because that's a great question. Okay, all right, so you should hang on, come on now, there we go. Y'all should see my screen now, or yep.
Yeah,
All right.
okay. Yeah, we can see you.
So let's say payment processing. So I'm going to use, and you may use different, let's say we use Stripe or Square, something like that, right? So we have our user, and maybe you do your own payment processing, but we really encourage folks to use, some type of service. So API and Lambda. So what happens is they make the request, I make the request to Stripe, and I may do several things, right? I know with Stripe, I had to work on this where I had to build like a subscription out, and there were some things that are happening but they still need to be asynchronous. They needed a response. But what happens again, like I said, if this Lambda goes down, then we got a problem, right? It's going to going to have errors. So here's what you can do on this. With step functions, you can do what's called a synchronous invocation with step functions. And this makes it really cool because a step function, then that step function can call as one of its tasks. And if you're not familiar with step functions, I highly encourage you to look at it. It orchestrates movements. Excuse me. As one of its tasks. So instead of, you can invoke the step function directly, then you can call Stripe, and maybe you do a couple things, couple of lambdas that are doing that. And then it returns to the user. And this is all done synchronously. So what happens is, if in this first example, like I said, if this Lambda fails, then you're out of luck. In this example, if this Lambda fails, step functions, you can automatically configure it. You don't have to do it in your code. Configure it to retry. And you can say, look, I want to retry twice. If there's still a problem, then we go back to the customer and say, hey, it seems we have a problem with our payment service, whatever. But this allows you to do a synchronous version, but still storing or persisting the data first. Now, it's not a persistent, and this is great for PCI and stuff. It's not a persistent in the way that it's like, look, that data's around. We've stored your credit card. It just keeps the data until we have said, yes, it worked, and you may move on. So this would allow, hopefully this would answer that question of, what if I want to store it first, but it still needs to be synchronous? This is a great answer to that.
Yes, thank you. Because we have to know when to use it, because maybe some of the times we overcomplicate our solutions. Maybe the use case is simple, and we don't need asynchronous in that form. So thank you. It was great use case without.
Absolutely welcome. Thank you.
Anyone else? Any more questions, since we have Eric with us? Okay.
All right.
Okay. Thanks, Eric, for really an insightful presentation.
Yeah.
And I'm really sure everyone is eager to put this knowledge that they gained here into their work.
Okay. Hopefully, and yeah, like I said,
you
can find me at EDJ Geek on Twitter. I'll put that in the chat real quick. If you have more questions, I try to answer. I'm going to be real honest. I'm not always the fastest, but I try to answer them. Feel free to reach out to me. Follow me. I'm always pushing new information. But I love doing this kind of stuff. And first of all, the team that set this up for Dan and the whole team, thank you so much. Y'all did great, and this was a lot of fun, and man, I just appreciate it.
Yeah.
And I still plan
we
to have.
we hope that we will have you again, and hopefully next time will be in person here in Pristina. So yeah,
That'd be great. Oh, looks like we have another question.
Okay, you did tell us what you don't like on pizza. So, which pizza do you like?
Pepperoni, black olive, and sausage is my favorite pizza. It's pretty plain. I'm okay with that. I believe pineapple shouldn't be in the same restaurant as a pizza. And I know that causes conflict, but you know I'm right. That's just the bottom line. So yes, hopefully that. I'm sure there's debate in the room. My wife and daughter love pineapple on pizza, and so I order it for them, but I can't do it on like, oh, just do half of a pineapple, like half of mine. No way. I don't even like the juices on it. So I'm quite passionate about this, as you can tell.
Okay, so thanks everyone for attending today's meetup, and look forward to meet every one of you in person next time.
Thank you.
Thanks, Eric.
Oh,
Thank
you
you.
bet. See y'all later.
Thank you.
Bye bye.
Bye-bye.
Bye.
Bye.